Hello, in this video I'll be showing you how to answer the BMAT 2004 Section 2, Question 15. So we have two circuits here, and 5 statements about these two circuits, and we're asked to indicate whether each statement is true or false. Our first two statements talk about when we close the switch S1, so we'll focus on that first. So our first statement, when the switch S1 is closed, the voltage will increase. So we can see that when we close S1, that means we've added this cell in parallel. However, this additional cell will make no difference to the voltage, and our voltmeter reading will still be the same, which makes statement 1 false. This may go against your intuition, but you should know that when you add cells in parallel, the voltmeter would read a voltage of one of those cells. On the other hand, if you added those cells in series, your voltmeter would read a potential difference of the sum of all of the cells. So moving on to statement 2, when S1 is closed, the current in ammeter will increase. So we know from the previous statement that the voltage has stayed the same, and we haven't changed our resistance. And you know that V equals IR, so that means that our current will stay the same. And this makes statement 2 also false. So let's move on to statements 3 and 4, which talk about the switch S2. So statement 3, so when S2 is closed, the current in A2 will increase. So initially, before S2 was closed, the current only had one direction to take, and that was through A2, through the bulb, through A3, and back again. However, when S2 is closed, we have an alternative path, as it can now go to this light bulb. So how does this affect the circuit? Well, adding a light bulb in parallel will decrease the total resistance in the circuit. As say each light bulb has a resistance of R. Then before the switch was closed, the resistance was just from this light bulb, so it was R. However, when the switch is closed, we have this additional light bulb, and when we add resistors in parallel, our resistance is given as the sum of 1 over this resistance, and then we flip it over. So that will give us our resistance of R over 2. So by adding a light bulb in parallel, we have halved our total resistance. So that means less resistance we have more current. So the reading in the ammeter will increase, so that makes statement 3 true. Statement 4, so when S2 is closed, the current in A3 will decrease. So you may think that because we've added an alternative pathway, that the current will be split between the two, and that means that the current will decrease. However, this isn't the case, as when you add in parallel, the voltage on each branch remains the same. So our voltage across this branch is the same as it was before, and our resistance of this branch hasn't changed, so that means our current wouldn't change. So that makes statement 4 false. Finally, statement 5. So when S3 is closed, the current in A2 will increase. So what happens when we close S3? So when we close S3, it actually shorts out the circuit. As you know, that current likes to take the path of least resistance. Because if you think about it, if you had the choice of walking down 2 corridors, you would choose the one that's least crowded. So that means our current will go around this path and avoid the ammeters. So you get a huge drop in the ammeter reading, and essentially it will be negligible current going through. So that makes our last statement 5 false.